I want to move on to our closing remarks, and they will be presented by Maja Matarić. She's our interim vice president of research at USC, but she's a Soon-Shiong distinguished professor of computer science, neuroscience, and pediatrics with a long and distinguished career on AI and robotics, from conception to implementation to dissemination and outreach to commercialization. So we're very lucky to have Maja to give us some closing thoughts on this symposium on AI and data science.
Thank you, Yolanda. It has been an amazing 3 days, and I decided to be totally selfish. And instead of doing high-level closing remarks, because so much has been said, I thought I would throw out something very concrete, which is a little bit more science. I wanted to do a bridge to yet another field that is relevant to what we've talked about over the last 3 days, data science, AI, machine learning. I want to throw out something that's important as well, which is another field that bridges, and that's robotics. And so I'm going to use my little time to do that, and I hope folks will be engaged and interested. I want to talk a little bit about AI and ML, and of course, data science as a cross-cutting area in the physical world. And of course, robots are the place where we do that. And so, if you think about robotics as a field, we have sort of perception, planning, action, and interaction in the physical world. And perception is now all about learning. So we really, everything we do with vision, tactile, audio, now NLU, NLP, psychologic data, physiologic data, everything is related to machine learning. Now, those fields don't necessarily work well enough together. Sometimes we have to reinvent it in, quote, our own field in robotics, and that's too bad, which is why I'm making this point now. But it really is all about learning now. Planning and control, again, learning at all levels, whether we're talking about continuous control, all the way up to very Bayesian and even more discrete reasoning. It's all about how do we do real-time behavior under uncertainty, with absolutely learning as a necessary component. And then, to me, most interesting, I'm biased, is interaction, this mutually adaptive behavior between the machine and the user, or a set of users, or even lots of machines and lots of users. So I want to spend a little bit more time on that and really show folks how this bridges to what we've talked about in the last 3 days, so I can sort of inspire and connect better. So let me go really briefly to tell you about the field of human-robot interaction. So here's a quick redux. HRI is really about anything that involves a physical machine, or more than one, and at least one human. It could be in the environment, or it could be in the control loop. So that's a giant umbrella, right? We have assistive, social robotics, socially assistive, medical, rehabilitation, service robotics, human-robot collaboration. It's a huge field, and it's booming by leaps and bounds, and it connects to so many other things, right? So for example, people might have heard about soft robotics as being a major area of growth, and it is. And what is that about? It's about having completely new ways to physically interact in the world with AI empowered systems. So it's just one example, but there's so many. We're talking about people being inside machines, having their bodies augmented by machines, having our minds augmented by machines, and of course, having our behavior supported by machines. And in some sense, in robotics, we still split physical and social HRI into separate fields, just because they're both very hard. Of course, in the future, these have to come together. But I will take the little bit of time I have to talk about social HRI. Until I leap into that, I want to make one high-level point, and that is that, at least in my world of robotics, and I would say in all of AI, we need more balance. So we need to spend more time on augmentation, which is the enhancement of human ability, and less on automation. And so I really want to focus on work where machines are helping us do our own work, rather than necessarily doing that work for us. Yes, some work should be replaced, but a whole lot of work can be empowered. So that is in particular what this field of socially assistive robotics is about. And we did start that at USC. It's a thing now. It's big and broad. And it's wonderful to see collaborations across campus and, obviously across the world over these really hard problems. And the nexus is really that we're looking to develop machines that will empower people in their behavior change, right? So the idea is that, so many things in life are hard, from doing the right things to adhering to medical things to, getting your vaccines, et cetera. And that's really a convergence of disciplines in order to nudge human behavior. One can argue that really behavior change is the ultimate problem when it comes to humans, because if we get people to behave properly, then, you know, we could solve so many problems. At least that's how I like to think about it. No shortage of problems. And so we've worked for the last decade and a half in the wild a lot, in a lot of different complex domains. And so I just want to inspire with a few examples that really bridge across AI, data science, and ML. So here's some current work going on with, I would say, the cutest participants that you can imagine coming up here. Never too early to start doing AI and robotics. And so we're looking, for example, at the problem of kids whose development is affected and delayed by any number of reasons. It could be autism, it could be physical developmental delay. It's 1 in 6 children that are affected in the US. Some recover, some don't. So what can be done? Well, it turns out we can't even assess or diagnose this early on, right? This problem of classification and diagnosis is very, very hard when you have a moving target like infant development. So here's a great example where you have multimodal sensing coming together with machine learning in order to do prediction and fun things like we can predict where the infant will look, so we could draw their attention, and by drawing their attention, we control their behavior, because infants are relatively simple in terms of what they can do, and therefore we can get them to imitate some really powerful behavioral outcomes. Here's another area, helping people to get along and cope. I think we can all relate to the need to cope better over the last year or so. And there's some really exciting work on looking at moderating group interactions by formulating the problem as sort of resource allocation, which is a very AI-ish way to look at things. But then you get into all kinds of interesting things like, what are you optimizing? If you balance the input of different players in the group, you get things like reduced selfishness and improved trust. And this is very important in things like mediation of support groups. For example, we're working now with cancer survivors. So really exciting areas of promise that you might not think of. Another one is healthy habit formation. I'm a big fan of behavior economics. There's so much we can do to help people develop healthier habits that will, in the long run, result in behavior outcomes. But, you know, how do you do that? What is the cue? What is the reward in forming new habits? So we've done some work with the elderly. We had some amazing outcomes, right? Leaving a robot in the home of an elderly person for 2 weeks. You could change their behavior in terms of how much they walk and sit entirely. Sadly, once you take the robot away, they just go back to their old ways. So some really interesting things. Another really, really compelling area is autism. I'm just going to play a tiny little bit of it. This is a public video from Science Nation. I think, you know, if I wanted to inspire students, I would say, you know, 1 in 50 kids is affected by autism in this country, and this is a lifelong challenge. And so you're looking for some good problems to work on. Here's one.
Meet Adrian, age 6.
This is some great work.
And his robot friend, Kiwi.
You are doing an amazing job.
On this weekend morning, they've settled in to play some games, along with Big Brother Darren. Adrian is on the autism spectrum, and Kiwi is no toy. It's a socially assistive robot.
So the thing that's interesting here is that the physical embodiment of the robot allows you to collect much more interesting multimodal data through a social dynamic. And that's very important for AI and machine learning in terms of the quality of the data and the context of the data. So I think this is where, again, we need to talk about fields coming together, because a lot of the work today is still not using really interesting, rich multimodal data, and certainly not in context. And so what we really need is we need these opportunities to do long-term personalization for individual users in HRI, in HCI, in AI more broadly. But we need to get the data in the real world through an interaction dynamic. And that's where robotics really comes in, because it's a real-time interaction in a noisy real-world context. But then what you get out is amazing. Like something like this, where you have a child learning in real time with a completely autonomous coach that is adapted to their own specific needs. And I just want to see a lot more of that. We're not seeing enough of that yet, and that's a pity, because we could. So to finish, I just want to say everything we've heard in the last 3 days has been about the potential empowerment of really humanity, if you will. It's not too far to say, of well-designed human-machine interaction and well-designed AI. And we can do a huge amount, but we really, really have to work on real-world problems in real world contexts, not just in our labs, and with real data. And we have to create data and we have to share data, and all of that could be done better. And I want to just give some props and kudos to CASE++. That's the undergrad student group in the Viterbi School and across USC. And these students have made a pledge to work on societally relevant problems. And I had the opportunity to watch some of their projects just a couple of weeks ago, and I was blown away. It's just, we have some amazing students, not just at CASE, but it's amazing. So I can't wait to see this generation do way better than, we have so far, but we have a ways to go. So I will end with that and just say that this has been an honor to participate. And just what an amazing group of people. Let's keep this going, and let's chip away at these really hard problems.
Thank you so much, Maja. I want to thank our 30 plus speakers that have participated in the last 3 days. We have heard all sorts of interesting ideas in sustainability and health, but also how data shows up everywhere in our cities, in finance, in logistics. We have heard a lot about how we model humans, their behavior, but also their language and culture. So lots of interesting topics for all of us. We've also covered education. I'm very proud to have been able to offer you such a wide range of great research at USC at the intersection of AI and data science. This is our second USC AI Futures Symposium that we have held this year, and we hope to be able to bring you additional topics in the future. So please stay in touch. And thank you to all participants that have made time in their day to join us. Many of you have come in and out, but we are very happy that you were able to make time in your day. The recordings will be available in the next few days, so you can share the link to this meeting with your friends and colleagues and students, and help engage everyone in great research in AI and data science. Thank you, everyone. Have a great day. We'll see you soon.